Hi friends and my dear students. In 12th Physics, today we are going to see the atomic spectra, and specifically for 5 mark question, Spectral series of Lyman Ballmer Parched Brackett and Fund series. Before going to see the 5 mark questions, let you know something about what is meant by atomic spectra. When you consider a solid or liquid or gaseous state, when you are applying the heat energy, then it may emit the radiation. Then you get a continuous spectra. As per the ancient scientists explained that it was continuous spectra. But later, in early of the 20th century, when the material emitting the radiation, then the radiation which represent the characteristics of the material, that is, and also these spectral lines shows that it is not a continuous spectra, but it is a line spectra only because of possessing different wavelength, particular wavelength sharply. That's why it's said to be continuous spectra, not continuous spectra, but it should be a line spectra. That's why it was explained. Instead of continuous spectrum, the radiation contains of a set of discrete lines, each with the characteristics wavelength. In other words, the wavelength of the light obtained are well defined, and the position and intensities are characteristics of elements as. That is the very importance. These wavelength are explain the characteristics of the element. That's why the continuous spectra must be avoided. We are considering only the line spectra in early of the 20th century. That's the thing that we are going to study already about the continuous and line spectra. Today we are going to explain spectral series of Lyman Ballmer Parched Brackett and Fund series according to the line spectra for an hydrogen atom. There is a very important 5 mark questions that you have to clearly understand. Whenever, suppose you have considered the figure 1, this is called figure 1, this is called figure 2. As for the figure 1, this is called ground state. In ground state, we already know that the energy of the electron in the ground state, that is equal to minus 13.6 electron volt. Below that, there may be minus 15, above that, minus 10, minus 5. So within the period of interval of minus 3.4 electron volt and minus 13.16 electron volt, there is two orbital. One is the n equal to 1, first orbital. The first orbital energy level equals minus 13.6 electron volt. In the second orbit, the energy of the electron is nothing but minus 3.4 electron volt. When you consider n equal to 3, that is equal to 1.5 electron volt. We already studied about the value of these all things in the previous chapter. And when you consider n equal to 4, that is equal to 0.85. And above that, if you consider when n E equal to 0, the energy of the electron is equal to 0, that may be called as ionized atom. It may be called as ionized atom or continuous energy levels. Continuous energy levels. This is the graphic figures tells us the important points to us. Now, if any electron are in the higher level, for example, an electron in this is called n equal to 1 and this is called n equal to 2. When the electron in the highest state will be stable at 10 power minus 9 second, 10 power minus 8 second, 10 power minus 8 second itself, it may be stable in the excited state. After that, it radiates the energy, again come back to the normal state or in the ground state. During this period, they may be emit the radiation. That is the history of the line spectra. Now, when you consider, if suppose the electron are jumping from the second orbit to the first orbit, there may be one line spectra. When you consider n equal to 3, or jump over from 3 to first, there may be another line spectra. Likewise, you got more lines from higher energy level to the lower energy level in the first series or ground state. That is called Lyman series. This is called Lyman series. Similarly, if the electron are jump from higher energy level to the second orbit, that may be called as Ballmer series. In other words, if suppose the electron are jump over from the higher orbit to the lower orbit n equal to 3, then it may be called Parched series. Parched, P-A-S-C-H-E-N, Parched series. Then another Brackett series. Suppose when n equal to 4, if you draw the graph like this, then this may be called Brackett series. Suppose when n equal to 5, then here this is called Fund series. Brackett series, Fund series. When n equal to 1, you get Lyman series. When n equal to 2, you get Ballmer series. When n equal to 3, you get Parched series. When n equal to 4, you get Brackett series. When n equal to 5, Fund series. That means the electron may be able to jump from second to infinite orbit to the first orbit, then you will get a Lyman series. In case the electron are able to jump over to the third to the n orbit, then you will get a Ballmer series. Likewise, you get when n equal to 3, electron are jumping from fourth to nth orbit to the level of third orbit, then you get partial. This is a very good explanation to understand the figure. So what is this spectral series? These are all the spectral series. For hydrogen spectra, we get the spectral series of 5. One is Lyman, another is Ballmer, Parched, Brackett and Fund series. Now, if you want to find out the wavelength, we know the value of the equation C by V. C by V, or C equal HC by E2 minus E1. The energy difference, H is the Planck constant and C is the velocity of light rays. So you can calculate the wavelength, specific wavelength. These are called the history of the how we are obtaining the Lyman Ballmer Parched Brackett and Fund series. These are all called spectral series. Spectral series. Okay, with the help of the second figure, we explain. If you consider Lyman series, this is called wavelength figure. If you are increased, this is a lower wavelength. This is lower wavelength, 0 to n, 0 to n. Suppose the Lyman series are started with the wavelength of 91 nanometer, and ended with the wavelength of 122 nanometer. This is the width of the Lyman series, and this width are shown in the ultraviolet region. The Lyman series just behind the visible light, just behind the Ballmer series, are in the ultraviolet region. In case, suppose one more question may be asked like this: what is the width of the wavelength of Lyman series? 91 nanometer to 122 nanometer. What is the width of the Ballmer series? 365 nanometer to 656 nanometer. What is the wavelength of Parched series? 820 nanometer to 875 nanometer. 1875 nanometer. This is called width. This is called width of Parched series. This is called width of Ballmer series. This is called width of Lyman series. Now, Lyman series are lying in the category of ultraviolet region. These alone we are able to visualize, and that one is called Ballmer series. One famous question may be asked in the successfully was past 30 years. In which spectral lines we are able to visualize the object? In which spectral line? Spectral series, we are able to visualize the object. Ballmer series. That's all. This is called visible light. This width alone called visible light, VGR. Above that are called infrared rays. So center is visible light. In the above wavelength are called infrared. In below the visible wavelength, then it may be called as ultraviolet wavelength. Now, we want to find out, to explain the 5 spectral series as per the equation. Rydberg constants are Bohr atom models. Rydberg constant are Bohr atom models. Now, nu bar, what is the wavelength? Nu bar, it is nothing but wave number. It is nothing but reciprocal of the wavelength. This is called wave number. So you must understand clearly, when you put nu bar, it is reciprocal of wavelength. It is equivalent to 1 by n1 square minus 1 by m square. n1 square, 1 by n square into minus 1 by m square. This is called, here one constant must be here, that is called Rydberg constant. This is a equation to find out the wave number of any spectral, any particular lines of any series. That is a very important equations. From this we can explain the Lyman series. Suppose when 1, we can explain the Lyman series. Lyman series. Lyman series, it is nothing but n equal to 1, comma, m equal 2, comma 3, comma dash 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 up to n. That means the electron can jump from second, third, fourth dash dash orbit to the level of first orbit. Then we get Lyman series. That is a very important explanation to obtain the Lyman series. Now the wave number is equal to Rydberg constant into 1 by 1 square minus 1 by 2 square dash square, that is equal to 1 by m square. This is the equation to explain the Lyman series. This is the equation to explain the Lyman series. The second one is called Ballmer series. Ballmer series. Ballmer series. Ballmer series is the same way, like that same equation, nu bar is equal to r into 1 by 2 square. Here instead of here, n is equal to 2, n is equal to 2, comma, m is equal to 3, 4, 5 dash dash dash. That means the electron can jump from higher energy level of 3, 4, 5 dash 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 to the level of second orbit. Then we get Ballmer series. That is a very important equation. That's why we are putting 2 square here and 1 by m square like this. Here it may be r into 1 by 4 minus 1 by m square. This is Ballmer series. The equation for wave number of Ballmer series. Ballmer series. And third one, the wave number of Parched series. Parched. P-A-S-C-H-E-N. Parched series. This is the equation. Nu bar is equal to r into 1 by 2. Instead of 1 by 2, we have to put 3 square minus 1 by m square. Here n is equal to 3, m is equal to 4, 5 dash 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 dash. That means higher energy level of 4th, 5th, 6th dash dash dash, so on, jumping the electron from higher energy level to the level of n is equal to 3, then we get Parched series. So this is the equation to explain the portion, and we have to reduce this, then 1 by 9 minus 1 by m square. This is the equation for wave number of Parched series, and this is the equation for Ballmer series, and this one is called Lyman series. Lyman series. And another fourth value that is called bracket series. Bracket series, it is nothing but n1 equal to 4, comma m equal to 5, 6, 7 dash 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 dash. So that we can write the equation nu bar, that is equal to r into 1 by 4 square equal to 1 by 16 minus 1 by m square. And this is the equation for bracket. And the last one, fund series. Fund series. Last one is fund series. Fund series. Fund series, you can say n1, n equal to, not n1, n equal to 5, comma, m equal 6, comma 7, comma 8, dash, 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 and so on. So that we can substitute the value of r into 1 by 5 square, that is nothing but r into 1 by minus 25 by 1 by m square. And this is the equation for explaining the wave number of fund series. This is very, very, very important equations of spectral series of Lyman, Ballmer, Parched, Brackett, Fund, and the wave number equation is given by nu bar, that is equal to r into 1 by 1 square minus 1 by m square. These are very important question, 5-mark question, frequently asked in the annual examination. Try to understand all concept clearly so that you have answer for all 3-mark questions as well as or 1-mark questions. So what is the bandwidth of Lyman series? It is nothing but 91 nanometer to 122 nanometer. What is the equation of Lyman spectral series? Nu bar equal to r into 1 by 1 square minus 1 by m2 square. Here n equal to 1 and m equal to 2, 3, dash, dash, dash. This is the value of equation for spectral series of Lyman of wave number nu bar. These are the method to understand the concept clearly. I hope you may understand the concept clearly, and a very, very important question for your annual examination. Try to understand the concept. If you have any doubt, then put a comment, then I will clear once again. Okay, thank you.